Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at Valentine's power couple, math and Python. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make those tough to teach, tough to learn concepts accessible to all my students. With us tonight, we have Julie Riggins and Adam Pinnell. Julie Rockstar Riggins was a math teacher in the Winston-Salem County school system in North Carolina for 26 years before retiring in August of 2020. She now enjoys being a stay-at-home mom for her 16-year-old daughter, Grayson, and going fishing on the Outer Banks with her father. She's been a T-Cubed instructor for 13 years and loves teaching teachers how to use technology. So, Rockstar, thanks for joining us tonight.
Oh, I'm not going to let you live that one down. All right. Thanks, guys. Happy to be here.
And Adam received his undergraduate degree from the University of North Carolina and completed his PhD in mathematics at North Carolina State University. He taught for 3 years at Bluefield College and has spent the last 24 years of teaching at Greensboro College. He's a T-Cube national instructor and loves exploring new ways to help students learn. When Adam is not teaching, he enjoys spending time with his wife and son. He's married to Janet for 30 years, and his son is almost 12. So, Adam, glad you could be with us tonight.
I'm glad to be here, even if I'm not a rock star, but that's all right. Okay.
Well, you know, there's still a lot of time in the webinar. You could get better. And Julie is going to discuss our agenda tonight.
Right, so we just had our welcome and introductions, and the first thing we're going to do is explore Python Valentine's Day heart activity with linear and quadratic functions. And then we're going to build a program in Python to illustrate slope by delivering flowers. And stick around to the end because Mike is going to do a drawing for a TI handheld. So you want to win that.
Perfect. Thanks, Julie. And Adam is going to discuss our expected outcomes.
What we're hoping you can do is you leave this, want to be able to have you say, I can use Python to engage my students in learning about linear and quadratic functions. And that was the one that kind of goes with my activity. And the one that goes with Julie's activities, we want you to be able to say, I can illustrate the concept of slope through building code in Python. Basically, we want you to be able to use Python in your math classroom. Give you some ideas for that.
Thanks, Adam. We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Julie or Adam using the Q&A window on the right side of your screen, and we'll also be using the chat window tonight to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance, as well as a link for the documents at the conclusion of the event. With that being said, Adam, it is all yours. Feel free to share your screen.
All right, so here we go. There we go. All right. Hopefully everybody can actually see my screen.
Looks good.
You can? Good. The activity that I'm going to do is going to use Python basically to draw a heart and then fire an arrow through it. Now that's the fun part, but the purpose is I want to sort of enhance or help students learn about the quadratic and linear functions. For anybody that's curious, this, and you'll see it as we go through it, this program and this activity is set up for people who really don't know that much about using Python. The program's relatively repetitive, and the idea will be, you know, show some code, let the students put in like the function, and then say, hey, okay, now do the next piece. Just take the code you have and modify it. And basically, we'll just keep alternating between giving code and letting them modify code to produce the program we're going to do. Now, obviously, I'll be doing it all this time, so it won't be any students at all. For those of you who are really more 84 users, just want you to know that this is, I'm doing mine on the Nspire. Julie will do her activity on the 84, but both of them could be done on either platform. Actually, my program would be put in, well, the menus are arranged slightly differently, but the code will be the same, except at the beginning of the 84, you need to put a clear screen. You'll see that with Julie's activity. And at the very end, you need a command that says show plot, just so the plot will stay on the screen. Not necessary with the Nspire, but all the code and the whole activity works exactly the same except for those two additions. All right, so let's go ahead and get started. All right, if I was starting this activity, and by the way, there is part of the handouts, there's a student activity guide and actually a blog that could kind of work as a teacher's guide if you wanted to. And the student is part of the files that we shared. But what we would do first is I want the students to build kind of the environment we're going to work on. And like I said, this is designed for people that don't know much about coding. So first, we need to add a Python program, an editor, and shell technically. But I'm going to just call mine heart because I'm going to draw a heart. Name it whatever you want to. And once we start the program, really the first thing we're going to be working with the plot module. And one thing about Python is it comes in kind of lean. It doesn't have a lot of commands kind of built into it. Think of it, I've heard this comparison before, it was an empty bookshelf, well, with a couple books on it. And what we want to do is basically we're going to put one more book on there so we have all the commands for plotting. And what we need to do is just hit menu. Like I said, we're going to be using a lot of this plot library. And all you got to do is put in the one statement. All right, now we have all the plot commands. We've added the plot module. Now, once we're started, what we need to do is we want to create the environment. And so we want to create our graph, our grid, and all the little stuff that goes in there. And so we're just going to go to the plot library and set up. Now, as we do this, we're going to just start first with the window. And by the way, if you're new to Python, I really recommend you work out of the menus, because as I put in the command here, you can see that, it says what we're putting in. Now, for this particular activity, -2, 10, -7, and I think 3 was what I picked. We'll know in a little bit if it looks stupid. So now we've got a window. I'm going to put in a couple more commands, then we'll see what this looks like. All right, next, what we're going to do, go again to the plot menu. That'll become kind of old after a little bit, but still. And just keep going down the list, and we're going to put in a grid. I like the grid because it'll help students see where each of the points are that we put in. And I think for mine here, scale of 1 will work. Style is, pick your favorite. I kind of like dashed. And last, for the kind of basic part of the setup, come into plot library, just going down the list essentially. And I'm in the wrong one. And that is not at all what I want, which is just annoying. I knew I'd do something stupid before we went too far. Let's try again. Plot library, set up. Thank you. All right, I wanted to put in axes, and turning them on is quite sufficient. Now, what we want to do is just run this and see what it looks like. On the Nspire, it's Control R. And we have a nice little plot, and this will work great for us. The only thing is, to me, that's just not, it's kind of boring with the black and white. So let's add in a little color. Now, just come in here, and it's back to the plot menu again. This time I really do want to go into the draw menu, and I want to do color. Now here you can see we're using red, green, blue. They all vary, as it had the little pop up there for a second. It said between 0 and 255. Gives us something like 16 million different colors, but I want to make mine blue, so I'm going to come over here and just turn the blue on, then do Control R one more time, and we have the graph. Now we're set up to do the graphing and draw our picture. Now, especially if you're working with people that are new to Python, this is a spot that I would stop and let them play for a little bit, because I picked this as a very specific order, but they may not see what the purpose of the order is. So I would recommend letting them rearrange these and see what happens after they run it. And then they can tell you why we put it into each of these places. Also, at this point, I would play and let them play with the color, because I picked blue. There's nothing magical about it. Can they, do green? Can they do red? Obviously, those are easy. But what about orange? What about pink? What about purple? Whatever. Let them pick something. Let them play here for a little bit. Now, we don't have time for playing, so we're going with my blue. All right. So the next thing we need, well, if we're going to draw a picture, you need dots, because I mean, that's what people do. They draw pictures. They connect dots. Some of my best pictures are like that. So plot dots. Now, all right, mathematically, that is really bad. We would probably say a scatter plot or plot points, but I like my joke, so I'm staying with it. All right. This is really, in Python, drawing a scatter plot is not that different than on the 84 or the Nspire. We need an X list and a Y list. So I'm going to do XH equals. You can call it whatever you want to. Since your students are probably going to be working on calculators or handhelds, I would keep it short just because it's a little harder to type on them than it is on the keyboard. Now for mine, I wasn't terribly exciting. The X values are 3, 4, 5, 6, 7, and then we bounce over to, oh, I guess 5, go to 5 again, 0, and then 3. And we need Y values to go with these, so they're in the same order. So basically, like my first one's 0, so that's first point's 3, 0. Then it's 4, 2, 5, 0, 6, 2, 7. This one's not terribly exciting either. But then we get a couple, -4, -6, and -3. All right. Now we got our points. We want to plot these things. So back to the menu, and guess what? Back to the plot library to draw, because we want to draw something. And well, it's a scatter plot, so big mystery. Go with the one that says scatter. I mean, really, it is set up very nicely. And again, you see X list, Y list, so I just use XH, YH, and then go over one, and you get to pick your mark. I really like the circle because that just makes an enclosed point. All right, now we get to plot this, and we'll run it. Just Control R. There's our heart. Now the drawback to this, we're doing a Valentine's thing. Who wants a blue heart? We don't want to be blue at Valentine's Day. So we go back and change it. And this would be another place. Like I said, I'm just doing little things for beginning coders and say, now, can somebody make that scatter plot red? Because we want to do red for Valentine's Day. Now, we're not going to take much time. We're just going to go ahead and put it in. But again, menu, plot, yeah, you kind of got that out and down. Draw. And all we want to do is go back to color. And I suppose if your students don't want a red heart, they don't have to have one. But I kind of like it. So we'll now do Control R, and we got our red heart. At this point, we're set up to do the math. I mean, everything's been kind of all, well, Python-y so far. But we're going to do a linear function here, a linear function here, a parabola, and a parabola. Back to a linear function. This down here is our arrow, and then we'll fire the arrow to finish off the whole activity. Now, first thing we're going to do is we're going to draw our line. Now, let me just, you don't really need to do that, and probably causing myself problems down below, but we're going to put in hashtag. I didn't mention this. Whenever you put in a hashtag, this is how you can comment the code in Python. And we're going to do a line from, let's see, we're going from 3, 0 to 5, -4. Now, you wouldn't actually have to give this to the students. They could look on the graph and figure that out. Now, if we want to plot a line, if you weren't caring about the math side, you could just go on in here, plot library, do draw, then down here on our list is line. And I mean, quite literally, we could put the x1, y1 is 3, could put in 3, 0, and we could 5, -4, and we'd have a really pretty line. But like I told you, my purpose in this is not the pretty line, although I want a pretty line. It's to have my students play with the math and get a pretty line. So we're going to put in a function instead. So menu, and guess what? We break out of our plot library and we go to built-ins. And it's not a mystery which one's function. It says functions. We click there. Now you can call this function whatever you want to. I'm just going to call it F. Not terribly creative, I admit. Our argument's X, so that's what I'll use to create here. And the only other thing is you can see with the 2 spaces, anything spaced in twice is basically under this definition. And those are just regular spaces, or a tab would take you over to. And the last thing I need to add to this beyond the function itself is I need to go back to function and add the word return. Basically, you put in a value for X, it evaluates it here on the return line. Now we'll come back in a moment to the function itself. But now I have a function. I can put in my first value of 3, and then the second value is f of 3. And then we have 5, then over f of 5. And finally, mode. We don't really want an arrow on our heart, so we'll put in default. Now, for me, this is a great opportunity. You can talk about a little bit about the domain, where this is going to draw, restricted domain of the graph, because we're really doing a line segment. It's also great to work with students on function notation, because do they understand what f of 3 is? And let them play with that. Now, here's where the student's going to put in their function. Now, as we put this in, and anybody knows Python, yes, I just made a mistake, but I'm making it on purpose. So I guess that makes it allowed. And by the way, that's the wrong graph altogether. But let me just do Control R like I was writing this. If you get that syntax error here, it is just because in Python, if you want to write a function, you need to have the multiplication. It needs the multiplication. It's not going to interpret the 2 beside the x is multiplying 2 times x. Well, in this case, -2. But what I want our students to do is put in something, graph it, and look there and say, oh, that didn't connect the dots. Now, since y'all are pros and everything, I just wanted to put that in there. You don't need, you knew what the graph is anyhow. But there's our graph. Now, we can pick up the pace just a little bit. You wouldn't in the classroom. Actually, you'd probably be slowing down here. Because the next thing I would do is tell the students, hey, you got the code for the first one. Recreate that code and change your function so that it'll graph from -4, actually from 5, -4 to 7, 0. Now, on the Nspire, if you hold down Shift and just go down, it'll highlight. You can do Control C and then Control V. On the 84, it doesn't really matter. It doesn't, I mean, it's 4 lines. It doesn't take long, and you don't really need this one. Fact is, I am being very lazy here, and I'm going to say line 2. I'm also being lazy just as I go through this. Normal practice would be to name each function something different, but we're going to use the function once directly below it, then do a new function. So just for time in this webinar, instead of labeling everything differently, I'm going to just use F over and over again. But here you'd want the function, the students to play. Now, the actual function you would put in is pretty easy, but they would have to go figure it out from the points. 2x minus 14, and then they'd need to change this to 5, f of 5, 7, f of 7. And then we do Control R, and we got our second line. Now, obviously it'd take a lot longer in the classroom for this because the students would take longer figuring that stuff out. And I just apparently, here, I was going to make a point and I touched the keyboard. Anyhow, we're now going to do 2 parabolas and get those into this thing. And I know Julie's working, but I can usually do this last part much faster than I did the first part. She doesn't really want me to take up all her time. I don't know why, but okay, just kidding. Now we're going to do, we're basically going to go from, see, 3, 0, I'm not going to type this in, to 4, 2, to 5, 0. By the way, I purposely picked these points so that 2 of them are on the x-axis and 1 of them is the vertex to give you choice on, which form of the quadratic function you would like to use. So it sets up nicely for the factored form and the vertex form. Now, my idea would be to do the same thing that we did a moment ago. So let's just go ahead and, oh, where am I going? Built-ins, come on, catch up. Thank you. Functions, define a function. And again, being very boring, I'm going to keep calling it f. I know, bad programming. And then go back up here and get a little return statement. And yes, you could type those in, but I am just modeling what I would want people to do. Now, at this point, I would have the students, you might stop and have the students play and figure out what that equation is, but I would probably go ahead and put in the code that will draw it so they can get the feedback, kind of a formative assessment, and see if they did it right. If it doesn't have the plotting part in here, then they can't do that yet. Now, the downside is quadratic functions don't, there's not like a line, there's not a quadratic, there's not a single quadratic command. So what we got to put in is we're going to have to use a loop. Because what we're going to do is draw a whole lot of small line segments that follow our parabola. And to do that, back to built-ins, but loops are under control. Technically, we're really going to be using this one, but I'm going to come down here just for a point. Index is I. What we'd like to be able to do is go from 3 to 5 with a step of 0.1. Well, we could say 0.1. Unfortunately, that doesn't work in Python. Python only wants integers for its steps. So what we're going to do is kind of be creative, and we're going to make this 30 to 50. Now, obviously, that's not where we want it, but then we're going to divide it by 10 when we put it in, when we do the graphing part. So again, we're just going to be doing lines again. So we're going to come in here and plot library, draw, and then a line. Just now we need to write our functions in terms of I. So I'm going to put in I divided by 10. Now, if you think about that, like when we put in 30, that's 3. That's where we're going to start. Put in 31, that's 3.1. So I'm going up by the tenths I want to. And then I'm going to use the function like we did before, f of I divided by 10. The next one, I'm just going to go forward kind of 1. So what I need to put in is I plus 1 divided by 10. So when the first one's 30, this one's 31. So it's a tenth ahead. Then put in f of I plus 1 divided by 10. And I hope I don't forget a parenthesis, because I usually do. And then again, just default. Now, I would personally, for new students, show them this part. See if they understand what's going on. Maybe even have them explain what's going on. Then come in here to the return, and they need to put in the function. And what it's going to be, I'll just go ahead and cut to the chase. -2 x minus 4 raised to a power. If you're raising to a power in Python, you do the 2 multiplications, squared plus 2. And if I haven't done anything stupid, there's that half. Now, the next half, I would do the same sort of thing that I did a moment ago with the linear function. I would copy this and ask the functions. Ask the students to modify it and make it work. We're just going to say we're not using these. I'm not going to take the time. So this is number 2. Thing is, if
Hey, Adam,
Yeah.
Can I ask a question?
Yeah, go ahead.
So the part of the parabola you just drew, that was basically 20 little lines. Is that correct?
Yeah, basically.
From 30 to 50?
Sort of. It's
Or is
actually,
it 200? Is 200 in it?
no, it's basically, it's one little segment. Each one of them is a 1/10 long. So it would be 28 little bitty things.
Okay, thanks.
Maybe starting at 0. Yes, that would work. Now for here, if they're thinking it's just a shift, I mean, it's the same graph, just shifted over 2 places, so they could just change that. And then all they'd have to do is change the range in here. We want to go from 50 to 70 now. Actually, the rest of the code still works because it's all in terms of I. And Control R, again, nothing stupid. We have our line. Now, to finish this thing off, we have one more line to draw, and then we have to make it move. Here, I mean, at this point, the students are old hats at drawing lines, so I just ask them to draw the line. I purposely put this so it intersected the y-axis so they could look at this very quickly. Now, we're going to do it really quickly. I'm just going to copy it over here because, like I said, you already know how to do this part. And I'm going to paste it in. Now, don't worry, we will talk about this just a little bit. I'm not just blowing it off. Here, let's just move this a little further out of the way. I don't guess I needed to move it that far up, but now, first we'll go up here. Here's the line I pasted in. Now that's exactly the same way we did it a minute ago. Got the function x minus 6. It intersects at 6, goes from 0 to 3. Now, especially for new programmers, what I'm going to do is show them this code and ask them, probably even start a conversation. I was thinking about doing it here, but I think I want to, well, I'll more just talk about it. I was going to ask for responses from y'all, but based on our time, I want to make sure we have time to do it all here. But I'd like them to look at it and say, well, how on earth is this making the line, making our line move? And now take a moment, I'll give you a second, just look at it. I think the big giveaway might be, if you don't recognize this, if you haven't played with the RGB, that 255, 255, 255 is actually white. So what this thing is doing, like I said, I would let my students play and talk about this for a while. But what this is doing, it's basically adding a little segment to the front of the line, then adding a little white segment to the back of the line. Keeps adding red segment, white segment, and so it looks like the line's moving. Yes, it leaves basically a contrail behind it, but it made the code simpler to do it this way. All right, so let's run it. And there's our line. Just fires on through. Now, do it again. If that line moves faster than you want it to, what you do is come back to this code. And we need to add one more command. But we don't have access to that command yet, so we need to add another module, another book to our bookshelf. The module, we want to slow this thing down, so we need something involving time. So we come down to more modules. There's a time module, and there's from time import. Now, we have all the time commands, and so we'll go back to the bottom. See, this is where I got in trouble by putting all those extra spaces in, is when I just scrolled down, it just shot past everything. And all I need for it to be in the loop is to put in 2 spaces. Now it's indented, it's in the loop, and go back to menu. And just do, not plot library, sorry, got so used to it, I went there. Time, and then I want sleep. Now I would have a little discussion. Well, I might even let my students play with it. What should I put in for time? If they're thinking, they're not going to pick something bigger in a second, because I mean, we're going from 30 to 130 in this one. That's 100 seconds. That's a lot. That's 2 minutes watching that go across the screen. To me, what ends up working fairly well is 0.3. Slow it down just a little bit if you want to slow it down farther. Obviously put a bigger number in. And I think students would enjoy that. You could ask them to play with this. Can you make your arrow a different color? What else can you do? I certainly think an extension of this would be, hey, you've played with this. Give them a setup and say, I want you to draw a picture using 2 different functions and make something move. I don't know what you would do, but and then let them have the freedom to draw their own graph. All right. But I think so that Julie, who's been very patiently sitting back here and chatting with everybody, has time to do her activity. I'll quit now. And let's see, we gotta turn that off. And guess I need to stop sharing. I don't know if I have to stop sharing, but anyhow. And I will try to pass her control if I don't do something stupid. You have control, Julie. It's all yours.
All right. Thank you so much. I just love Adam's little heart with the arrow through it. Every time I showed that to somebody, they're like, oh, that's so cute. Well, when I was asked to do this webinar on about Valentine's Day, my idea was maybe I can deliver flowers. Okay. So I thought, well, I will deliver flowers and maybe I can talk about slope, because I really like the idea of coding, but I also want to make it relevant in my math class, right? So I thought I could get my kids to maybe understand a little bit more of slope. And our intention, I think, as Adam said, we really want you guys to come away with this with some ideas of how you can use this in your math class, and the tools needed to make you feel confident that you can do this. I have not been coding in Python very long, only about a year. And the way I started was with 10 minutes of code on the TI website. They give you little modules that you can work through and really give you the basics of how to code in Python. When I got really into the nitty gritty, right, of doing this program, I'd have questions like, how do I do that? Or I wonder if I can do that. And so I needed even more resources. And so I used the internet some, but TI also has a guidebook for how to program in Python on the TI-84 and the Nspire. So that was really helpful for me to complete my project here that I'm going to share with you today. So we are going to get started. So I'm going to use the 84. Like Adam said, you could do this on the Nspire as well, but I wanted to give you the feel of how the 84 works as well. So on the 84, I'm going to go to Program, and I'm going to open up the Python app. And these are the programs that I have on my computer, or on my SmartView. And I'm going to scroll down here to FLDEL for flower delivery. And if you notice these menus at the bottom, or these soft keys at the bottom, this first one is run. I don't want to run this program right now. I want to edit it. And so edit is the second one there. And so that's going to line up with the window key on the 84. So I'm going to hit window. All right, and I've already got this started, so I cheated a little bit just to make sure we would get everything in that we wanted to. A lot of this is very similar to what Adam has already done. I love the way that he explains, how to import the libraries and how it's like a bookshelf. So I have my plot library imported there at the top. He also mentioned at the beginning about how with the 84, you have to clear the screen. And there I have my window set up, and I've turned my axes on. All right, so remember I'm delivering flowers. So I was thinking, okay, who's the couple that I could use to deliver flowers to? And of course, I grew up in the 80s, so I went with Jack and Diane. So I've got Jack's house at -5.3 and Diane's house at 15 -9. And I wanted to make this dynamic so I could put Jack and Diane's house anywhere on the screen that I wanted to. And I was thinking, I had been practicing this for, I don't know, a couple weeks. And I was like, oh my goodness, what if I have a zero slope? And or what if I have an undefined slope? So anyway, those are good things for kids to practice, right? After writing this program. So I have named, so I have some variables for the x coordinate of Jack's house and the y coordinate of Jack's house, and same for Diane, the x for Diane and the y for Diane. Okay, so I'm ready to plot Jack and Diane's house. So I'm going to go to the functions here. So notice the menu now has changed. So to get to functions, I'm going to choose y equals. And these are all of my menus, okay? So go all the way across here to module, and this is where the plot library is, okay? And this is what I'm gonna be using most. So I'm gonna go to module, I'm gonna go to plot library. Here's the setup screen. This is where we got the first line of our code. It's also where we got the second line of our code. I wanna point out in blue, the blue text gives you what is that code going to do? So this one is going to clear the screen. The blue text also tells you what your syntax is. What is going to need to be entered into this code once you go back to your program. So I'm going to go over here to draw. So I already did that setup part. So I'm going to go to draw, and there's my color. Notice, just like in the Nspire, it's red, green, blue. And that's why the RGB is there. It also tells me that my input numbers are from 0 to 255. So I'm going to start out plotting Jack's house. And just like Adam, if I'd known Adam was going to use blue, I might have used something different. I don't know. But I'm going to use blue for Jack's house. And now let's plot the point for Jack's house. So I go back to my plot library, number 5. And I'm going to go down to number 6. Which is the XY, and it's going to put a mark on there. I also want to point out the green arrows on this screen. The little green arrows on the right say that this is going to take you to another screen so that you can put what kind of mark you want on the screen for the house. And so for the houses, I'm going to use number 2, plus. And where am I going to put Jack's house? Well, I'm going to put Jack's house at XJ, YJ. Okay, then I'm going to plot Diane's house. Okay, so I'll go back to my y equals, back to my functions, over to the module, down to the plot library. And Diane, I'm going to change the color. Diane, I think I'm going to use red. And we will plot Diane's house just the same as we did Jack's. So the plot library, and we're going to go down to number 6 again. And Diane's house is at XD and YD. Okay. It's good practice as you're writing a program to run it every now and then and make sure it's doing what you think it's supposed to do. So I'm going to hit run. Notice where run is. It's the 4th button over. So I'm going to use trace right here. So if I hit trace, it should run this. Oh my goodness, it went away so fast. So notice that run key, when I hit trace, it ran. Notice now trace now is the editor. That run button right there changed to editor. So I'm going to hit trace again. That's going to take me back to the editor. And Adam mentioned this. And let's see, I've kind of cheated a little bit and put some stuff down here. And there it is. I'm going to put it below that code right there because I'm going to use that right now. So to get that plot to show, on the 84, you have to go back to the plot library setup and notice that number 9 at the bottom. Show plot. And in blue, it says it's going to display this, and it's going to display your plot until you press clear. Okay, and clear is also backspace on my computer. All right, so I'm going to use show plot, and I'm going to run this one more time. There it is. So we've got our window, we've got our axes, and we've plotted Jack and Diane's house. Now we are ready to plot some flowers. So the only way I'm going to get rid of this screen right now is to hit clear. So I can either hit clear on my calculator or backspace on my computer. I'm going to hit trace again to get back to the editor. And I'm going to start my flowers by plotting the stem. Okay, so my color, I'm going to need green. So no red, full green, and no blue. And I'm going to go back to my plot library one more time and use that number 6 one more time. And for my flower stems, I'm going to use number 3 there, the cross or the X. Now, who's delivering flowers to who? Let's see, we've got Jack delivering flowers to Diane. So I want these flowers to start at Jack's house. So this stem is going to be on X, J, and Y, J. Okay, so that's our stem. Now we need the petals. Okay, so I'm going to go ahead and change my color because I don't want green petals. Oops, go over to module and number 5 and draw. So I want pink petals. So how would I get pink petals? Well, I've played around with the color, and like Adam said, it's really important to give your students the opportunity to play around with the code, play around with the colors. Let me go ahead and put 255. So it's full, I'm using full red, no green, and a little bit of blue. And that's going to give me a pink color. So I have a student version of the activity as well. And Mike is going to give you these handouts at the end. And I think it's really important to have the students just try to, to be creative, play around with the code before giving them, hey, here's how I did it. And so I've tried to do that in the handouts that I created so that the code is hidden behind a little block. And so if you're using Google Docs or something, then they can read what they're supposed to do. They can even see some of the menus and play around with it. And then if they need help, if they get stuck, they need help. Or if they got something and they just want to compare it to some sample code, then they can slide that block out of the way, and then there's the sample code behind it. So there's sample code, and all of this is in the materials for the end of the webinar. Okay, so we've got pink. Now what I'm going to do is use a scatter plot like Adam did. And he told us when he was doing this that he was going to use, that to do a scatter plot, you needed a list. Okay, so let me give myself a little more space here. So I kind of cheated already just because that was a lot of typing. So if you notice here, I have created a list, and you know it's a list because of those square brackets, okay? So this first line is the X's for the petals, and those petals need to be centered on that stem. So that's why each of my elements in my list start with XJ, because that's the horizontal component for the stem. And then I've got the 3 petals kind of are going to be centered horizontally on that XJ. Same thing here for the Y list for my scatter plot. I called it YP for Y petals. And notice that each of these elements are above the stem a certain amount. So the first one's going to be up by 0.5, the second one up by 0.8, and the third one up by 0.5 again. So we've got these pink petals that are going to be centered around the stem. All right, so let's graph that and see what it looks like. So I'm going to go back to module and the plot library, and I'm going to draw a scatter plot. Notice here is where you see the syntax. This is where it says, oh, this is where I have to put my X list and my Y list. And what kind of mark do I want for my little petals, my little buds? I'm going to use number 1, the circle. And we are going to graph XP for my X list and YP for my Y list. And let's just run that and see if we have something that looks like a flower. There we go. So there's my bouquet of flowers sitting on top of Jack's house. All righty. So the next thing in the student handout that I've asked them to do is to calculate the slope. Okay, so we want to get from Jack's house to Diane's house. How are we going to do that? I would like for them to use Python to calculate the slope. And I'm going to show you how I did that. In the bottom right-hand corner here, you see files. So I have written a program called slope right here. And I don't want to run that program. I want to edit it so you can see it. So I'm going to hit Window. And so what this program is doing is it's going to our flower delivery program. That's what my program was named. And it's pulling in those variables that I used for Jack and Diane's house. And it's subtracting those to get a dy and a dx. And then it's going to print dy divided by dx on the screen for me. So that's what this program is going to do. I'm going to go back to the graph key, which is files again, and go back to my flower delivery program and edit it. Okay, so now I hope I didn't lose you there. But in the files, you can go to other programs. And so I mentioned earlier that TI has the guidebook for programming in Python on the 84. And in that, I found this really cool little tip. And that is, if I do second catalog, I get all of the codes that I can use in Python. So I was scrolling down through here just to see what all I can do, you know, because the menus are great, but sometimes if you don't know where something is, it's frustrating. So I was scrolling down through here. I'm going to hit the letter F. So I want to get to the code that starts with F. And then I got to this part right here, and I was like, that's what I want to do. I was wondering if I could write a program and then use it in another program. So notice what's in blue here. What's in blue is the word program. So when I put this on my screen, the from is going to be there, the import is going to be there, that little asterisk is going to be there, but program, I'll have to type in my program name. Type that in, and the program that I'm importing is slope. All right, I'm going to run this again, see what happens, see if I did that right. So we still have our flower on there, but notice now we have the slope was printed in the top of the screen. Okay, so we need to go down 12 and right 20. So my next question to the students is the next question I'm going to ask you. So I'm going to ask you if you can type something in the chat window. How many steps would you take to get from Jack's house to Diane's house? And I do not see the chat window. So Adam, if you could tell me if anybody enters anything there. If I want to go down 12 and over 20, how many steps should I take?
Okay, we got an answer,
Okay.
32, 32, 25, 23, 32.
These are great answers because they are not what I expected. Okay, so that is
That's a
telling me as a
23.
teacher, I am asking my question incorrectly. So I want to, so you need to help me now. How do I ask this question better? So I need to go down 12 and right 20. And I want to do that to illustrate slope. So I'd like to step to it. So like maybe instead, if I took one step to get from Jack to Diane's house, I would go down 12 and right 20 once. So what if I took 2 steps, right? If I took 2 steps to get to Diane's house to illustrate slope, I might go down 6 and right 10. If I went down 6 and right 10 twice, 2 big steps, I would get to Diane's house. So is there another number of steps? Oh, I saw somebody had 3/5. It's I saw a 3.
We got a -3/5.
I saw
We got
3/5.
a 20.
So that 3/5 is that reduction of the slope, right? Well, so let's go with that. If I was going to go down 3 over 5, how many times would I do that to get to Diane's house? If I were going to go down 3, yes, down 3 and over 5, I would do that 4 times. And so that's kind of the answer I was looking for. So if somebody could help me word that question better, I think I need a little help on that. So I want to do that in 4 steps. Okay, so here's what we're going to do. We are going to go back to our editor, just trace. And we are going to do a loop that's going to go through 4 times. And every time it goes through this loop, I need it to go down 3 and right 5. All right. So here's what we're going to do. We're going to, oops, I went all the way over to module, but really I want to be in control. Okay, so I just hit the Y equals, but I'm going to the control menu this time, and I'm going to do a for loop. Now, Adam used number 6 on here, and he used the step. And I'm going to use number 4 there. Notice what my input is going to be. My input is just the size. All right, and it's going to be 4. So I'm going to run through this loop 4 times. And I already have this kind of typed in as well. I'm going to show you another menu on here, and that's the tools menu. Remember at the beginning, I'd said that the show plot has to be at the bottom, or we're not going to see our graph. So I'm going to move this code up into my for loop. So I need to move this code out. And so I'm going to go to tools, which is going to be zoom. And I'm going to cut that line out. And I'm going to paste it down here at the bottom, which is zoom 7. Zoom 7 is paste. And there we go. All right. So here's what we're going to do. Remember what we're trying to do. We're taking that little bouquet of flowers, and I want to move it to the next XY location. So I need to move the stem. So the first thing I'm going to do is change my color back to green. And I've got the Y plotted already. I thought I would graph or type in the X. So remember, we're not going to stay at X Jack. We need to add to that. What do we need to add to it? And this is a good thinking exercise for the students. And they might need help from that sample code that you would provide for them. But we are going to add to the X coordinate the dx that we got from the slope, and you wouldn't have to call another program to do that. You could do that slope program right inside of this program. And we're going to divide by 4, and we're going to multiply by I. And that's going to make this happen 4 times. Okay, and I already have the y done, so it's the yj. We're going to increase the y coordinate by dy divided by 4. Okay, let's see what happens. I'm not going to do the next line until I make sure that this line works. So this is only the stems. So I'm going to hit run and see what happens. Okay, so notice how the stems started stepping over to Diane's house. And but notice they didn't quite get there. And the reason is in the for loop, the first time through that loop, I is 0. So if I need to get all the way to Diane's house, there's a couple ways to do that. And in the student notes or the student handout, I've asked them, how would you get it to go all the way there? And they might choose to change the range to 5. I, however, am going to add a 1 here. And you know what? I really want to make a mistake. I'm going to leave that parentheses out. I just think it's important to see a mistake and how to deal with it, you know? So I'm going to go ahead and set up the pink here. So these are my petals. There's the pink. All right, so there's a bracket, because remember for the scatter plot, you need a list. And so I'm going to type this quickly. So for all the x's, we are going to add dx divided by 4 times I. Oop, and I need I plus 1. I'll go ahead and put I plus 1. Now, this is a cool little piece of code that I searched. I Googled this one and found it. Watch this. Okay, so what we want to do is we want to add that dx divided by 4 to the x for every x in xp. So it's like a little for loop inside there that's going to add that to every x. And then I've done the same thing here for the y. It's going to add that for every y inside of the list yp. All right. Oops. Sorry. Let me turn my alpha lock off. And all right, let's run this. I did make a mistake, but I'm going to hit run because I wanted you to see what happens. So if I make a mistake, it tells you what line you're in. It says line 32. I've got a syntax problem in line 32. So I'm going to go back to my editor. At the top of my screen, you can see the lines being counted. I think it said 32. Because notice that both of these lines are called line 31. So because I know that my mistake, it got to line 32 and said, we have a problem. And that's because I left out the parentheses there. All right, so we've delivered the flowers. There's a couple more things I want the students to do, and that's to draw those vertical and horizontal lines in there to show the slope. And just to show you like a final version of what I'm hoping that my students will be able to do, I'm going to run this this final version. And notice how the flowers are being delivered. I've got some vertical lines and horizontal lines. I learned how to put text on the screen. I also slowed it down a little bit, and that was that sleep command that Adam used. So you can also do this in the Nspire, but I'm out of time. So let's see, I'll stop sharing my screen, and Mike, you can take back the control.
Awesome. Thanks so much. As promised, we are giving away to one lucky winner a TI graphing calculator of their choice. And tonight's lucky winner is Sarah Kaiser. So Sarah, congratulations. We'll be in touch in the next coming days here to give you a little more information about that and to get some information from you. To receive a certificate of attendance, please click the link in the chat window. also listed as a link for the documents that Adam and Julie used tonight, including their code. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Huge thanks to Adam and Julie for everything they put together tonight. Thanks so much to the both of them.
Thank you. It was fun. I learned a lot.
I enjoyed doing this.
And thanks everyone for joining us. We hope to see you back online next week. Happy Valentine's Day and have a great night.